Good morning, students. Hope you will be fine. Up till now, we have discussed this cyclic and non-cyclic photophosphorylation. We have discussed the photosystem first and photosystem second. Now, today we are going to discuss the comparison between the cyclic and the non-cyclic photophosphorylation, and we will take some characters. On that basis we will try to differentiate, we will try to compare between the cyclic and the non-cyclic photophosphorylation. Now, what are the various characters on which basis we are going to compare this cyclic and non-cyclic photophosphorylation? For example, we will write here the characters. We will write here the cyclic photophosphorylation, and in this last we will write the non-cyclic photophosphorilation. Now, what are the various characters? First character अगर हम देखेंगे कि cyclic फोटोफॉस्फोरिलेशन में क्या हमको बन जाता है, नॉन साइक्लिक फोटोफॉस्फोरिलेशन हमारे को क्या सिंथेसाइज हो जाता है, दैट इज द सिंथेसिस. In cyclic photophosphorylation, only ATP is synthesized. Only ATP. While as in case of non-cyclic, I would compare this cyclic photophosphorylation on the characteristics of this synthesis. On the base of synthesis, in case of cyclic photophosphorylation, only ATP is synthesized, while as in case of the non-cyclic photophosphorylation, ATP and reducing agent, that is the NADPH2, is synthesized. This is the one. Second जो हमारे पास है, on that basis oxygen evolved, whether the oxygen is evolved in the cyclic photophosphorylation or not. In case of cyclic photophosphorylation, oxygen is not evolved, while as in case of non-cyclic, oxygen is evolved. How it is evolved? Due to the photolysis of water, due to the photolysis of water. During this photolysis of water, 2 electrons, 2 proton, and the nascent oxygen is evolved. Then this is the second. First we have studied the what are being synthesized in the cyclic photophosphorylation. It is only ATP in case of cyclic photophosphorylation, and in case of non-cyclic photophosphorylation, both ATP and NADPH2 are synthesized. Characters: oxygen, whether oxygen is evolved or not. In case of cyclic photophosphorylation, oxygen is not evolved, while as in case of non-cyclic photophosphorylation, oxygen is evolved because of the photolysis of the water. This is the second. Third, अगर हम बात कर लेंगे, what is required for this cyclic photophosphorylation? That is the requirement. For cyclic photophosphorylation, only photosystem first is required, while as in case of non-cyclic, both photosystem first and photosystem second is required. Now, in case of this cyclic photophosphorylation, what is required? Only photosystem first is required, while as in case of non-cyclic photophosphorylation, both photosystem first and photosystem second जो है, they are required. Fourth, अगर हम बात कर लेंगे conditions, अगर हम बात कर लेंगे इसमें we will see conditions are many. In case of cyclic photophosphorylation, which will write here in this small a, first क्या है, low light intensity, that is the first. Second, अगर हम बात कर लेंगे second requirement, that is less availability of carbon dioxide, less availability of carbon dioxide. एक और हम इसमें देखते हैं, it takes place under anaerobic conditions. So these are the three main conditions under which this cyclic photophosphorylation takes place. That is the low light intensity, second less availability of carbon dioxide, and third anaerobic condition. What happens? First अगर हम यहाँ पर देखेंगे optimum light intensity, optimum light intensity. B, यहां पर हमको जरूरत, यहां पर हम देखते हैं लेस अवेलेबिलिटी ऑफ कार्बन, लेकिन यहां पर प्रेजेंस ऑफ कार्बन डाइऑक्साइड. सी हमारे पास है ये दिस साइक्लिक, इट टेक्स प्लेस अंडर एनारोबिक कंडीशन, लेकिन इट टेक्स प्लेस अंडर एरोबिक कंडीशंस. सो दिस वाज वन मोर. एक और कंडीशन जो हम देखते हैं, दैट इज द कंपैरिजन बिटवीन द साइक्लिक एंड द नॉन साइक्लिक फोटोफॉस्फोरिलेशन. दैट इज what we call as the electron source of electron, source of electron. अगर हम देखते हैं कि नो, इसमें साइक्लिक में नो एक्सटर्नल सोर्स ऑफ इलेक्ट्रॉन इज रिक्वायर्ड. whatever the electron is emitted by this chlorophyll 700 or P700, it is recycled back. So there we will see no external source of electron is required. Whatever, या हम कहेंगे simply electron emitted by photosystem 700 या P700 is recycled back. यहां पर क्या देखते हैं हम, एक्सटर्नल सोर्स ऑफ इलेक्ट्रॉन इज, external source of electron is required. External source of electron is required. What is that external source of? That is water, from which we will see. That is जो हमारे पास source है, the electron is pair of electron rather. Pair of electron is emitted during the photolysis of water. So these are some of the comparison between the cyclic and non-cyclic photophosphorylation. First one, synthesis. In case of cyclic photophosphorylation, only ATP is synthesized, while as in case of non-cyclic photophosphorylation, ATP and NADPH2 are synthesized. अगर हम ऑक्सीजन की बात कर लेंगे, ऑक्सीजन is not evolved, while as oxygen is evolved during the photolysis of water. That's the nascent oxygen. Requirements only photosystem first is, while as both photosystem first and photosystem second. What are the conditions which are necessary for this cyclic photophosphorylation to take place? low light intensity, less availability of carbon dioxide, anaerobic conditions, while as it is the optimum light, presence of carbon dioxide, aerobic condition. Source of electron. No external source of electron is required. Whatever the electron is emitted by P700, it is recycled back. So it is called as a cyclic photophosphorylation. While as in case of external source of electron required, that is the pair of electron that is emitted during the photolysis of water. This was all about this comparison between the cyclic and non-cyclic photophosphorylation. We will proceed further in the next video. Until then, goodbye. God bless you. Thanks.